Hello everyone, this is Bradley. So yesterday people asked me about this kind of icing drop animation by CG shortcuts in Cinema 4D. Initially, I've done similar kind of things in animation nodes in the past, and I don't think it's very critical for me to replicate this in geometry nodes since this is too basic. But since people asked about this, so I think let's just do this. So let's just start. So here we in Blender, as always, I'm going to use the presets which you can download for free from the link in the description. Let's start with a spiral, which is the most important part people wonder about. And let's cancel this height. Take the radius maybe to 0, and let's start with a bevel curve node. So we create a kind of volume of our spline. And by increasing this thickness, you can see there are some findings of our geometry. So I think the only way to resolve that is to increase the start radius a little bit, so we can manipulate the radius and so on to resolve that. It's probably not perfect at this moment, but I think you can try to resolve that more by manipulating these parameters. It's not very important in my opinion, so let's start with set the position to do our animation. Basically, by manipulating this offset, you can move that up and down. But we're going to create a kind of a mask or a differentiation so that some part is moved earlier than the rest of the part. Okay. So here, what do we do? Is to use a mixed vector node. Technically speaking, you should use a mixed vector node for almost all such kind of animation. And the mixed vector is very similar to the mixed RGB node that we use normally. But as you can see, one is working with the vector, the other is working with RGB. At some point, they're doing almost exactly the same function, but there are several issues. Other than that, this factor can be 2. Another reason is that it's not very easy to work with color to translate into a vector. The values are the same, but the color are supposed to be working in the range of 001. While it's definitely possible to work with 005, you have to always open this box and type in the values, while you can change all this kind of value as you wish in the mixed vector node. Okay. In the future, there will be more general mixed node available, I guess 3.2 or 3.3. So in the future, if you do not see this mixed vector node anymore, then please use this mixed node. Okay. And here we're still going to use the mixed vector node, and let's just play around with the vector A and the vector B, in which you start with a start destination and the end destination, playing with this factor as 0 to 1. Then you can see this animation. Okay, but it still does not solve the problem of differentiation, in which we're going to use either curve spline parameter or the index. Both ways are legit, but the issue of the index is it's working with the area vertices. Okay, so since we have about a 32 resolution, then we have a 32 index, almost. Just also to know that spline parameter also has an index, but it's for spline, so we only have the value of 1 for every point. So where it's not relevant. Okay. And knowing that our factor only works for 0 to 1, which means if you directly plug the index to factor, it will just elevate it infinitely to the sky. There's definitely ways to do that you use the attribute statistics and doing the map range. So finally to remap this index into the map range of 0 to 1 and so on and so forth. But that will be such a horrible idea to do. It will be easy if you just use the spline parameter. Let's do the spline parameter, in which you see that we have this 0 to 1 from the start to the end of everything. Okay, so to do the animation is very simple. Just add minus value, and you can see just by plus minus it just goes up and down. But if you try to clamp this value, then you can have a straight 0 to 1 manipulation. And I do not like the rotation in the middle, so let's increase the resolution so that you do not see it. And the rest is basically just to manipulate it. Okay. Here, let's do some more tweaking. For example, what we can do here, is right now we can see this is kind of a straight dropping down, which is not very interesting, and it's kind of a linear function. So I can take a float curve. A very important part you need to know about a float curve is by default it will clamp all these kind of value into the region of 0 to 1. It's very fortunate that we clamp this value, so we do not need to do extra map range in order to remap for the function of float curve. We can directly just manipulate this float curve so that it becomes a kind of a sharp descending and ascending animation, which is very cool. Another thing we can do is to deal with this kind of position. Okay, so by default there is already a position attribute linked to it. So even if you add a position attribute, it will not change anything at all. But you can do a vector math, and you can scale that up and down, and you can see this kind of effect. Okay, and here we're still going to use this parameter, and knowing that this value goes from 0 to 1 with our clamp. And here what we can do is to map range that, and map range from 0 to 1. Here I have another preset which is called remap 0 to 1. So instead of working with 5 sockets, I can only work with 2 sockets. It's just a personal preference. And I think we start from small to big because everything is being reversed somehow. Okay. So we started with small. The maximum is 0.5. And then by decreasing these values, it becomes large. So you can try to play around with it. It's just a personal preference and so on. So we can try to deal with that. Yes. So we have this kind of a dropping. Yes, I think this is cool. So you can tweak this by all. I'm going to use that as a subtract so that I can go from negative value to the large value. It's just more intuitive in my opinion. Okay. Next is about the instancing. The instancing is pretty simple. So let's start with a curve linear, which is really just a curved line node. Many people are confused about this node, but it's so simple. It's just a curved line node with some resample curve. And then point instance. So the spiral needs to be the instances and curve linear needs to be the points. And let's switch that onto the z-axis and use the step modes without the centering, and every time we deal with 2. About 2. Okay. There is some issue that you need to realize. That you realize this interval from interval, I thought there too. There is some reason to that. The reason is that we're working with the position and we scale that down. Okay. We scale that down at 0.5. So I do not want to affect the z-axis. So instead of working with the scale, I'm going to use the multiply. And I scale only at x and y axis, and the z-axis will be clean as 1. So now they are not being scaled on the axis. Okay. So I think this is cool, and then we are going to do the animation. Right now, if you try to play this subtraction, then you can see they're moving down at the same time without any differentiation. The reason is that you need to realize the instance so that you can access every single vertices. Otherwise, it's just kind of the entire instance is being moved. Okay. Realize the instance is very important. So here we play this animation and you can see everything is occurring at the same time. So although we have differentiation on each vertices for every spline, but there is no differentiation for every spline. What we do here is we need to use a delay Falloff to delay from spline to spline. Okay. We need to do this after or before or after realize instance. It's up to you. The only issue is that we need to either use the attribute instance, in which we need an instance, or we can use the attribute spline, in which we need a spline. So whichever way is okay. As long as you can get an index for instance or index per spline, it's okay. Okay. All this kind of attribute instance or attribute spline is basically just a capture attribute in relative domain. Here, I personally always prefer attribute spline. Let's just get this index per spline, and let's add a delay for. Delay for by default is working with the index attribute. But in this case, I'm not going to use the index, I'm going to use the spline index. So there will be a delay for every spline. And plug this for into the subtraction. We know this subtraction value goes from -1 to +1. And now if I play this animation, as you can see, it's not very obvious of the delay. So that you need to crank up this step interval, which means the delay from spline to spline in this case. Okay, and now if we play this animation, after finishing the first animation, we have the second animation, third animation, and so on and so forth. And we've completed it. The duration means how many frames it completes the transition from -1 to +1. So you can try to recall this kind of value. Okay, so basically we finished the animation with all this kind of icing, but we need to finish cookie as well. To deal with the cookie, it's also very straightforward. Actually, I do not really remember the original animation, but I suppose it's just a cylinder. So we also need to point in this cylinder. I want to keep the parameter the same. A nice part of proceduralism is that you can just use a single linkage in different places, so that when you change one, you change all of them. And here, let's just take a join geometry at the end. And we have, ta-da! Everything are instanced at the same place for both cookie and icing. So the way to resolve it is basically we are going to transform this curve linear a little bit. So maybe put that down and try to change these depths a little bit so that we separate them. Okay, this is nice. I think this is good. And then we need to play around with the animation. The animation is going to be pretty straightforward in my opinion. There are multiple ways, but I think the most straightforward way is you rotate the instance, in which you rotate the instance at local axis, as you can see, and you translate the instance. So you move that forwards and move that to the side way. Okay. After realizing these kind of changes, I suppose you need to understand. Oh wait. No. After knowing this kind of difference, yes, I suppose you can understand what we're going to do next. It's still the same. We're going to use the mix vector. Okay, and we are going to mix the vector into place. So we need the two mix vector, and we need to have the start location and the end location. So maybe that's 3, 2. The other is maybe whatever. Let's set a number. Take the factor into. Here we're working with a pi. I mean the radians. So like right now this is a degree, but 180 degree means a pi. So the value here in mix vector will be quite small. But anyway, you can just try to play around this value to see what does it look like. Okay, and we try to change this translation by taking a single value to control these two vectors. Then we can see this animation of dropping. Okay, and obviously the vector needs to be clamped so that you can see. Okay, this is good, but of course we do not have a differentiation from cookie to cookie. Then we need to do the same thing of getting an index and try to do the delay for. So here let's duplicate a delay for, and because we are working with the instance already, so by default the index attribute, which is built inside, I mean the index attribute is already using the index of instance. So we do not need to do anything specific. We can just directly use this delay for, and we can use the delay for to replace the factor but just to know that we need to change the value from 0 to 1. Okay. There are other things that we need to do, but we can actually see the results. So let's start with animation at 1, and if we play this animation, you can see the cookie and the dropping icing are occurring at the same time, so there are lots of issues. Okay. To resolve these kind of issues, it's a little bit of mathematical problem that you need to deal with, but basically what it does is we need to have the cookie animation occur earlier than the icing. Okay, so the delay, I think we need to -15. So the time is being manipulated earlier by 15 frames. And we also need to manipulate this kind of duration and step interval. So I think it's duration -25. And then we play this animation. And you can see some effects of that. And then you try to deal with that kind of value. Basically, I think what will happen is that the step interval will be the sum of two duration. So in this case, it will be 50. And then let's play this animation. Hey, and we finished that. I'm going to kill the variances so that there won't be any potential problem. It can be possible that you still remain the variances, but the seed may not be the same, so I don't want to mess up with that. And yes, this is it. And finally, you can play around with this, but I think this animation is already being done. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.